Okay, during this video we're going to practice how to uh, identify slope in many different scenarios, and then we're going to use that to derive an equation, and that's going to be the majority of what we focus on during this video. Before we go too far, I do want to kind of point out this new item, which should be something that we've seen in the past, but let's just kind of review. This is what we call slope-intercept form. It's called this way because well, first of all, it's a way to write linear equations or relationships. And it's called that because we know that y is going to equal some number times x plus another number. Okay? But what we know is that this number in front of x will always be m, which we know m is slope. And so when an equation is written in this form, like this one, we know that this number right here in front of x will automatically be our slope. And so the advantage to having an equation written in this form is no matter what, we don't have to calculate, we don't have to use the slope formula to calculate slope, we don't have to use rise over run, we don't have to think about unit rates or rate of change. All we have to do is just look at whatever number's out in front of x like that, and we know automatically that m in this example would equal 1/2. The other thing we know about slope-intercept form is this intercept part. This b right here is going to be our y-intercept. What that means is, like if we look at a coordinate plane, this being our y-axis and this being our x-axis, I'm just going to draw a random line in here. Our y-intercept, as we talked about earlier when we talked about intercepts, our y-intercept, this point right here is the y-intercept. It's where it crosses the y-axis. Well, when an equation is written in this form, we automatically know that whatever number at the end is going to be our y-intercept. We use the letter b for y-intercept. So in this example, b would be 3. So what we know about this graph, or this line, is that it's going to cross the y-axis at 3, and it's going to have a slope of 1/2, which if we think about it, that means that we're going to be rising 1 and running 2. And so our y-axis will be like this. It's going to cross the y-axis at 1, 2, 3, and we're going to be going up 1 over 2, up 1 over 2, up 1 over 2. We're rising 1, running 2. So slope-intercept form is a really cool form, and it's really beneficial for us to be able to gather a lot of information relatively easily. So we're going to use this form today. We're not going to be really given many equations that are in this form. Instead, we're going to actually derive equations once we know the slope and the y-intercept. We're going to put them into this form. So let's look at example number 1. They give us, and I had to blow up the picture, so it's a little bit tough to read. I'll go through here and just kind of 1, 3, 4, 5, 7, 9, and 11, and these are 1, 2, 3, 4, 5. You should be able to read these on your paper. But the first thing we're going to try to find is our slope, and then be able to come up with our equation. Remember, our equation is y equals mx plus b, where m is our slope, and b is where it crosses this y-axis. Okay? Well, we should be able to look at this graph right off the bat and say, well, this is where it's crossing the y-axis, which happens to be at 0, 0. So we know that the y value here where it crosses is b equals 0. Okay? Now we need to find the slope, which is what we're asked up here. This is where it gets to be a little bit trickier. And we need to understand that this is actually graphing some information here, and we're comparing time versus distance. And this distance is going to be in miles. Okay. What we want to look for is some exact intersection points. If we look here and here, these are going to be our exact intersection points. By using these exact intersection points, we can now use our rise over run method. We're going to be going up 1, 2, 3, 4, 5. I can jump up each square like this because each one represents 1 mile. So we're really counting off 1 mile, 2 miles, 3 miles, 4 miles, 5 miles. So we're rising 5 miles. Then we're going to be running 1, 2, and those are in minutes. Okay. So we're rising 5 miles, running 2 minutes. That's going to be our slope, or our slope is going to be 5 over 2. Okay. If we wanted to convert it to a unit rate, we could. We would actually end up getting, I'll tell you what, we'll do that here in just a second. Unit rate, I'm going to make a note down here so I don't forget. And we'll show how that's still going to be increasing at the same rate. But what I want to keep our thought pattern on is being able to come up with this equation now. Now, if you look, this is very close to our y equals mx plus b format. The only thing being left off is this plus b. The reason why we left this off is because if you notice, we already found out that b equals 0. So if you'd like to write it in as plus 0, we can do that. But we know that any number plus 0 is just going to give us, it's not going to change it. And so there's really no need to write plus 0 there. But this number, this blank space out in front of x is what we're looking for. Since it's y equals mx plus b, this m is our slope. And so all we're going to do is just take our slope, 5 halves, plug it in there. I'm going to simplify this down so that we get 5 halves x. Because again, there's no need to have that 0. But 5 halves x is the equation of this line. No matter what numbers we plug in, we will get the equation of this line. So let's test it out. If we know that x equals 4, okay, we can plug that in. Y equals 5 halves times 4. We know that x equals 4. So we're going to try to figure out, will that actually give us this point right here on our line? Well, 5 halves times 4 is the same as 4 over 1. 5 times 4 would be 20. 2 times 1 would be 2. 20 divided by 2 should give us 10 miles. So if we go up to 4, then we should have y equals 10. When x equaled 4, y equaled 10, so we should have the point 410. If we go over to 4, up, we need to see is this point at 10, and it indeed is. And so that just proves that this equation, no matter what you plug in for x or what you plug in for y to solve for the other one variable, will give us a point on this line. This is the equation for this line. All we had to do is use rise over run to find our slope, and then plug that slope into y equals mx plus b. Now, I really wanted to show you how unit rate is the same here as the 5 over 2. If our rate is 5 over 2, we're going to divide both by 2 to get our unit rate, like we did in the last video. And we get 2.5 miles per 1 minute. And so if this unit rate is true, we should be going up 2.5 miles, and that should give us an intersection at 1 minute. And so if we erase what we've got here, and we go up to 2.5, start at 0, 0, go up 2, and then just a half of 1, so right about there. And then we're going to go over 1. We should have an intersection right on the line, which, as you can see, we're definitely there. So we should be able to now go up another 2.5. So here's our half, and then 1, 2, and then over 1. And again, we're on that line. So now we go up another 1, 2, and then a half, over 1. Again, we're on the line. Here's our half, 1, 2, over 1. So as you can see, the unit rate is an example of a simplified version of our slope. They're still going to go up at the same amounts. Unit rate rate of change, slope, all of them are going to give us a great representation of the steepness of our line because they're going to give us points on the line. Linear functions are proportionate, so they're increasing and decreasing at the exact same rate. Okay, let's look at example number 2. This time it's given a table. We need to find our slope given this table. Remember, slope is just the changes in y's over the changes in x's. So we can use this to be able to say, what's our changes in y's here, and what's our changes in x's? So if we plug those in, we're going to find our slope. So as you can see, to go from 40 to 80, we're just adding 40. 80 to 20, we're adding 40. 20 to 60, we're adding 40. And so the change in y is really just plus 40. Our change in x's is going to be plus 5, plus 5, and plus 5. So we're going to put the change in x's as 5. Because we have these constant rate of changes on both the x and the y, we have proven that this is a linear function, which is good because with linear functions, then we can use this rate of change like this because it's going to be a constant rate of change. So now we simplify this down. 40 divided by 5 gives us 8, so our slope is actually 8. Okay. To find our b is a little bit more difficult. Okay. We've got to think about this in terms of a graph. So let me draw a line here for our graph. If we had x's here, and hopefully it gets to the point where you're able to just kind of envision this in your head. But for the first one, we'll just kind of demonstrate it here with a quick makeshift graph. So we've got 40, 80, 120, and 160. We know that we have at 5, it's 40, at 10, it's 80, 120, and 160. It might be off a little bit because I'm kind of free-handing this, but we need to figure out where is this going to cross our y-axis. Okay, so when it's crossing our y-axis, our x value is going to be 0. So really what we're trying to find is if we were to insert another box right here into our table, what would happen when x is 0? Well, if you think about it, that's just continuing the pattern, because if we reverse this pattern, we had it as plus 5 to move downward, but if we're moving upward, because we need to move upward now, because we need to figure out how to get from 5 to 0, we're really just subtracting 5 to get up. And so 20 minus 5 gives us 15, 15 minus 5 gives us 10, 10 minus 5 gives us 5, and then 5 minus 5 would give us 0, which is good. Now we need to figure out what's y going to be when we keep this pattern going. So again, we've got to reverse our pattern. 160, we're really just subtracting 40 to move upward, or up the ladder. And so 40 minus 40 then is going to give us 0 as well. So what we've done essentially is proven that this graph is going to intersect the y-axis at 0. Which means if it's intersecting at 0, our y-intercept is 0, or b equals 0. And so again, just like the last example, we're going to be adding 0 to this, because y equals mx plus b. And we know plus b when b is 0. Our m is 8. We can simplify this, and y equals 8x. For our next example, there's one piece of information that's left off. I want you to be able to figure out this information right here. I want you to put y equals 3x. I want you to finish solving this. I want you to graph it. And then I also want you to find the slope. Okay. Now you should be able to cheat based off of what we just learned to be able to find a slope right off the bat. But I want you to kind of connect the dots between all three. So go ahead and do all three, and we'll talk about it tomorrow. Good luck.